that. Okay, for this one, did we notice that that top triangle was isosceles? You didn't really have to use it because they did show that that was theta, and I think, did they show both of the thetas? Oh, not, sorry. So I'm supposed to actually have a step there. Okay, my apologies. Which one was given? B. Okay, so the one at C. Okay, so you must just add in before calculating A. Sorry about that. ACB was equal to theta, and the reason for that is because they told us that both of these are K, right? So you would have to say angles opposite equal side, sorry. Okay, you have to say that first. Then you would use get angle A, because guys, remember we're trying to find the common side always. All right, so what we're trying to get to in the end is this CD, which they labeled with a lowercase d. But in order to get to that side, we need to get the common side between the two triangles. The common side is BC. So I thought, okay, let's try and use sine rule. Okay, I also looked at what they asked us to prove, and there were no causes in there. That's why I thought, okay, let's try and use sine rule instead. But I think if you used cos rule, you could have kind of done some manipulation to get to it anyway. All right, but if we want to use sine rule to get BC, we need the opposite angle, okay, which we didn't have. But if that's theta and that's theta, do we agree that this is 180 minus 2 theta, right? So that's what I did next. Angle, sum, and triangle. Then I used sine rule. BC over sine of this is equal to, now you can choose either one of these two pairs. They're exactly the same. K over sine theta. Sine 180 minus 2 theta, that again is quadrant 2. And sine is positive in the second quadrant. So this is actually just positive sine 2 theta, which I then move to the other side. Okay, and I got an expression for BC there, which is the common side. Again, if you don't know how to go further, you can at least get marks for doing that bit. Okay, so do that at least. Okay, then in order to find D, I just looked at what we have here. It's actually quite nice because if we looking for D, we had the opposite angle, and we just found an expression for BC, and we actually had the opposite angle to that side as well. So we didn't have to calculate any other things. We could just use sine rule straight away. So D over sine alpha is BC over sine beta. Then I just multiplied the sine alpha on the other side. Now guys, this is that manipulation that I showed you yesterday, where if you take the BC out of the fraction and then substitute it with the expression that you got at the beginning, right? You can just multiply the numerator and the denominator. But guys, it's actually fine if you go from this to the answer straight away. Okay, you can kind of do that bit in your head. Where BC is K sine 2 theta, so the K sine 2 theta is going to have to go at the top over sine theta, so the sine theta has to go to the bottom. All right. Any questions on this one? Okay, number 2 was a bit longer and a bit more complicated. So for 2, I just drew the picture there on the side. For 2.1, they asked you to find an expression for angle ADC, which is this angle over here, in terms of X and Y, I think. That was the question. So everything in blue is what was given. And guys, remember, they won't give you parallel lines if you're not supposed to use them some way. Okay, so something that we could notice straight away is that we have a Z shape over there. All right, so I thought, okay, let me find that angle. It's easy to do that because I have a 90 and I have an X, sorry. So the third one will be 180 minus 90 minus X, right? Which will give you 90 minus X. If you work that out, I'll just write that down. 180 minus 90 minus X. All right, have you found that step to get that angle? And then because of alternate angles, and the fact that these two lines are parallel, if that is 90 minus X, that one is also 90 minus X. Okay, and we have that Y. So to find ADC, we would have to say 180 minus this whole angle minus Y. Right, are we fine with that? Then I multiplied my -1 in. And guys, the reason for me doing that is because I actually have a number in that bracket now. And I can actually simplify 180 minus 90. Okay, if I leave it in brackets, it's going to be more complicated than it should be. All right. So I multiplied it out. That this gave me negative 90, and we know that 180 minus 90 is just 90. And a negative times a negative there is positive x. Now it's fine if you left it like that, guys. All right. But I knew, like I said to you yesterday, we are probably going to have to use reduction formula going forward, which is why I decided, in a sense, I'm taking out -1 as a common factor here, because I want to put the y and the x in brackets. Okay, so if I want it to be -y plus x, then I have to write that as 90 minus in brackets y minus x. I hope that makes sense, because if I multiply that -1 in, what's -1 times y? Negative y, right? And -1 times negative x is positive x. Okay, so guys, it's fine if you left your answer like this, but then you would have had to do this work, this manipulation in 2.2. Okay, in order to simplify that angle, like we spoke about yesterday. So maybe if you didn't do that in 2.1, just write that in now. It does make the rest of the question simpler. Okay, so now we have that angle, 90 minus y minus x. Then they asked us to find, what was this now again? AC. Oh, that's the side that I clicked in there. Let me just go over it with a highlighter as well. And they asked us to find an expression for AC in terms of x and y and a also. All right, so now we're finding that side. Now, guys, do you realize now why they asked us to find ABC? Because ABC is the opposite angle, right? So we need to try and use sine rule. So then you need to ask yourself, okay, if we wanting this side, we have the opposite angle, we need another pair. Okay, we have that angle, but do we have AD? No. We have that angle, do we have CD? Okay, was CD given here? No, but notice that CD is a side in this triangle. And CD is actually the common side between this middle triangle that we're trying to work in now and this right angle triangle that we haven't used at all. Okay, it's again a case of they're not going to give us this triangle if we don't have to use it. All right, so that, it was difficult to come to that conclusion, but that will be our next step. We actually need to find an expression for CD so that we can use sine rule in this middle triangle. I'm going to go through that again quickly. AC is what we're looking for. We just found the opposite angle in this question. Again, guys, with these questions, if they're giving you sub questions, they're kind of leading you in the direction that you need to take. All right, so that was a hint. The fact that they asked you to find ADC is telling you, okay, you need to use sine rule. Okay. Then we have that angle, we calculated it, the 90 minus x. We need to find this side, which we can find because it is a side in this right angled triangle. So let's see, guys, in the right angled triangle, we have x, and they've given us a as well. All right. So x, a would be the opposite side to x. And the one that we're trying to find is the, which side is this? Adjacent, right? Which trig ratio works with opposite and adjacent? Tan. So tan of x is a over CD. Right, you can look at those three lines there. That is what I did to get an expression for CD, which I need in order to use sine rule. Okay. Are you all fine up until this point? I still following. Now after that, yes.
Yeah, if you use the angle, could use the angle BC and let's say that DC was the opposite and BE was the.
Yes, so this would then be 90 minus x. In which case you would have tan of 90 minus x, which you have to change to sine 90 minus x or cos 90 minus x. What you can do is just, that part is a bit complicated. But yes, you could do that. Because we don't have a co-ratio identity for tan. Okay. All right, guys, now after that, you are going to work in this middle triangle using sine rule, and you're going to find AC. But the actual manipulation of all the angles and so on, that is a bit complicated. But essentially, we're using sine rule. Okay, so we're going to say AC over sine of this angle, which was this whole thing, right, that we calculated up here. Do we see why I put the y minus x in brackets? So that I can get rid of that 90 minus. Okay? So it's AC over sine of the opposite angle is equal to CD, which I did find there, but I'm going to sub that in later. CD of sine of the opposite angle over sine of the opposite angle, which is 90 minus x. Which again, I'm going to have to simplify. Guys, what do we use when we have 90 minus? What's that word? 90 minus is reduction formula, but it has a specific word, a specific name, co-ratios, hey? Sine of 90 minus needs to change to cos. Did we remember that? So in my next step, I kept my fractions as they were. I just changed sine of 90 minus this whole bracket to cos of that bracket. Right? Because sine of 90 minus is equal to cos. That's important. Same thing here. Sine of 90 minus x is cos x. Okay, so you actually had to use your co-ratios twice. After that, we do what we've always done. We multiply the cos y minus x on the other side. Now, this is where I left out that step, right? CD was a over tan x. So I know that a has to go at the top and tan x must go at the bottom. Sorry, there. Okay, are we fine with just subbing it in straight like that? So you have CD. So because CD was a over tan x, you're going to put your a at the top and your tan x at the bottom. Now, guys, usually it would be okay to leave this like this, I suppose, but they told us what we had to prove, right? And there was no tan x in what we had to prove. There was, in fact, a sine x in the denominator of what they asked us to prove. They asked us to show that AC is equal to something. Now, here's where you need to remember your identity. You need to remember that tan is sine over cos, right? And what is this cos and that cos at the bottom? They are going to cancel each other out, and we are then left with that sine x. Let me know if you have any questions on any of those steps. You want me just to go over any of those? So guys, it's almost getting to the point now where using cos rule and sine rule is not the most complicated thing, right? The more complicated part is actually manipulating all the stuff that's in the sine rule here. Okay. Now I'm going to give you more to practice, but just make sure that you copy all of that down, please, so that you have the correct answer in your book. Okay, your work, you're going to do it now and you'll have to finish it for homework, is the same exercise. So I'll just write that again. So exercise 7, which was on page 226. Want you to do number 3. Guys, I just need you to check in my textbook 3.2 is wrong, the way in which they've written it. So can you just check? It says that you must prove that AC is equal to something, but the way that it's printed in mine is wrong. So just check that it says this. People might have fixed it in previous years. Okay, Okay, that's what you have to do in 3.2. Is that too small? I can read it quickly. It's AC is equal to, at the top of the fraction, D sine, and then in brackets, theta plus alpha. Alpha is that fish one. Over sine, in brackets, alpha plus beta. Right? It's printed incorrectly in some books, so just make sure that you are doing the right thing. And then from exercise 9, so it's just 3.1 and 3.2 for that one. Exercise 9, which starts on page 230. I would like you guys to do sorry, I'm just checking. Number 1. Okay, tomorrow we're just going to mark these, and then we're supposed to move on to functions. All right, we're supposed to finish this topic tomorrow. So guys, you'll see for exercise 9, there are some circles there. All right, so you need to remember your circle geometry rules. Angles, what's all of those things? Angle at center, angles in same segment, all of that stuff. All right, that's also actually a part of these questions. So for exercise 9, you need to look at that. And that is then the cutoff for your test. Okay, we haven't done the proofs. I'm going to give you guys a printout of the proofs tomorrow, and we're just going to go through it quickly. And I will also upload videos for you, so that if my quick explanation is not adequate, you can go watch the videos step by step, look at it. Just hold on, but we do have to start with functions tomorrow, probably in the second half of the lesson. Okay, we don't have a lot of time to do functions as it is, and it's quite important going forward. Yes, Talia? On Tuesday. I told you at the end of last term already, and first day of this term. Yes, it's Tuesday next week. Trig equations and this chapter. Yes? Functions is the last section, yes. So we need to try and finish it so that we have some time for revision also before your exams. Okay, guys, so Tuesday, Mrs. Glenda did ask me just to help her. For some reason, she doesn't have access to post the practice test, so I'm going to do it quickly after school. So the practice test is going to go up this afternoon. She's been struggling to get it up. So practice test will be up, and then it's on trig equations and this whole chapter. Okay. All right, guys, get going on number 3 there, please. Should I put it on the board for you? Number 3. All right, look at that, guys. That's number 3. I just want to give you a hint here because we haven't worked with angles of elevation and depression in a while. Here, they don't even have to say it in a sense, but these are all parallel, okay? You can put it in on your picture in your book if you want. All right, that's how it works. If they're showing you those dotted lines, then they are parallel to the ground in this case. Right, so there you might have to use alternate angles, co-interior angles, and corresponding angles possibly. So just make sure that you put those arrows in there. So just check, guys, that is what I told you must fix. You see in my book, the D sign is on the side. It's not a part of the fraction. So just check that. Yeah, but it's like you can't really have a sign in front of a fraction like this. But yes, so the D sign must just go at the top. Okay, get going, guys. Let's just talk about